Okay, so last time, if you remember, what we did was we were in, polynomial long division. And also what we were dealing with, and also one of the theorems I showed you was the remainder theorem, which is here, okay? And again, this just says that if you take a polynomial and you were to divide it by x minus a for some number a, you can actually get the remainder even without doing the division. It turns out to be just f of a. That's what it turns out to be, f of a, okay? That's what it turns out to be, and it's really just from the division algorithm, okay? I did go through an outline of a proof last time. It's actually on these slides, so I'm not going to go through that again. From there, you can actually get what's called the factor theorem, which tells you which allows you to figure out whether x minus a is a factor or not. It turns out that x minus a is a factor of f of x. Here's what I want to say. X minus a is a factor of the polynomial if and only if f maps a to 0. So you can actually figure out if x minus a is a factor of the polynomial without doing any kind of division or factoring. You just can do a polynomial evaluation, so to say. That's just the factor theorem. Again, I did this last time. It's in the notes, so not really going to go through it again. Okay. We did some examples last time. This example dealing with synthetic division, and you can actually use synthetic division to carry out polynomial division. If your divisor, remember, is x minus a number, like x minus a, then you could dive right in the synthetic division. For other cases, when you have something like x plus something or a times x plus or minus something, there you have to do modifications because it has to be x minus a number. Or you could just do polynomial long division. That's fine also. But this is synthetic division. This example we did last time. I'm not going to go through it again. Okay. In the old set of notes, okay, the rest of the slides you can in the previous set of notes, the rest of the slides you can actually, I guess, ignore, because I originally was going to do this example, dividing this polynomial by this using synthetic division. You could do that. There's some manipulation you have to do first. So what I'm going to do instead is just polynomial long division. Okay, so that's what I'm going to do, polynomial long division. Okay, that's what I'm going to do. All right, so as you can see, both polynomials are in standard form, which is good. Okay, also there's no missing terms right here. This is a polynomial of degree 3, but the term of degree 2, degree 1, and the constant term are there. Right? So we don't have to use 0 as a placeholder in either one of these. I mean, here it's degree 1, but the constant term is there, which is degree 0. So we don't have to use 0 as placeholders. So what do? We're going to set it up like this, and then we divide. Well, actually, we just divide leading term of the dividend by the leading term of the divisor. Okay? That's what we do here, as you can see. Okay. When we do that, we have 25x cubed divided by 5x. 25 over 5 is 5. X cubed over x, you subtract the exponents, and you get x squared. So we get 5x squared. Okay, that's what we got here. Now, and notice where I put it over the like term in the dividend, okay? Then what I'm going to do next is I multiply it, right? As you can see, I'm multiplying it, and then we subtract the product. So we get 25x cubed plus 15x squared. Okay? And we want to subtract that. Now, last time when I said subtract, you changed this minus to addition, but then you distribute a negative. I mean, you could do that, but I think it's just better just to distribute the minus sign. And once you distribute the minus sign, you eliminate the parentheses. So it's not wrong to think of subtraction as adding the negative, but I mean, it's not wrong to do that, but I think it's a little bit better just to distribute the negative. That's all. And that's what I did here, right? So now we combine, you know, these terms go bye-bye. Here we have 150x squared minus 15x squared, and that's going to be 135x squared, as you can see. Okay. And what happens next? The 131 comes, we bring the next term down, right? Now, I know from here we can see that we're not stopping, but how do I know that we have to keep going? Well, the degree of this difference is 2. It's bigger than the degree of the divisor. What you only stop when the difference has degree less than the degree of the divisor, or when the difference is 0. So in this case, we have neither of those two, so we keep going. This is basically our, so now what we do is we divide the leading term of this by the leading term of the divisor. So we have 135x squared divided by 5x, as you can see. Doing so, you get 27 times x. And as this green arrow is trying to indicate, you put that over the like term here, right? 131x. You put that over the like term, okay? Now we multiply and subtract the product. That's what I'm doing here. Okay, that's exactly what I'm doing here. Okay, good. Now, just like before, we distribute this negative and we throw away the parentheses. That's what I have over here, right? I thought I made a mistake, but I did not. So again, I distributed the negative, and then we take the parentheses away. I mean, again, you could have addition here. That is, you could think of this as adding the negative and distribute the negative then. But just distributing the negative is fine. That's what I'm doing. So now these cancel. We have 50x. The 30 we bring down. Are we done yet? Not quite, because this degree equals the degree of this. So what do? We do the process again. The leading term here, which is 50x, divided by 5x, right? That's what we're doing. We get 10. Because the 50 over 5 is 10, the x's cancel. And the 10 we put above the 30, okay? So now we have 10. We're going to multiply that by 5x plus 3, excuse me. We get 50x plus 30, and subtracting it. Yes, I guess you do distribute the negative, but hopefully you can see from here you're going to get 0, which we do. I mean, if you distribute that negative, these are going to cancel, we get 0. So as you can see, you know, we stop because now we have 0. Our quotient is up here. Okay, that's our quotient. And the remainder in this case is 0. Okay, so that's what we get here. Are there any questions about this? Okay. Now this is sort of a slight generalization of the remainder and the factor theorem we saw earlier. Namely, before we had x minus a number, a. In this case, we have a times x minus b. A can't be 0. And what this theorem is telling us is, you take a polynomial, right, f of x. If you divide it by a times x minus b, right? If you divide it by that, the remainder then will be this constant. That's what this remainder theorem is saying. So again, if you take a polynomial, capital F of x, if you divide it by a times x minus b, okay, what you get is this. Excuse me, the remainder, what am I saying? The remainder is going to be this thing. So you can get the remainder without actually dividing. Again, it's really just from the division algorithm. That's what it is based on. Okay? And it's really proved in a similar way to how we proved the other remainder theorem. You know, you just use the division algorithm, and the remainder, you know, has to have degree less than the degree of the divisor, which is what you're dividing by, or it has to be 0. So either way, it's a constant, because degree 0 means you're a non-zero constant. From here, what we also get is the polynomial has ax minus b as a factor if and only if this holds. So you could tell if this is a factor of it or not by just doing this calculation. Again, it's a factor because if and only if the remainder is 0, and since the remainder equals this, it's equivalent to saying if f of b over a is 0. And in fact, since we got a remainder from the previous example, right? If we were to evaluate this, well, let me be a little bit careful. You could use the theorem for ax plus b. The only difference, though, is that instead of plus, you have to replace this by minus. So you would have 5x minus negative 3 in this case. Basically, your a would be 5 and your b would be negative 3. So since this is this here, when we divided it by this, since we got remainder 0, that told us this had to be 0. And you could check in your calculator, it does actually hold. I did check in mine. Okay. And even if we wanted to divide, right? If we did this calculation first and saw we got 0, well, we knew we had to get a remainder of 0, which is good. Okay. I hope that made sense. Are there any questions on this? Let me stop.